Welcome back, students. In this video, we're going to cover Lesson 5-4. This is Proving Triangles Congruent, ASA and AAS. So this is angle, side, angle, and angle, angle, side. So we got three standards, GR 1.2, 1.3, 1.6. So we'll get right into it. So angle, side, angle congruence. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So our example, ABC and XYZ. Now, the letters in their order is important because that's how we identify corresponding parts. So your first letter, A, goes with X, B with Y, C with Z. And likewise, so AB, that's this line segment, that's the first two, or this side, excuse me, that's the first two letters, so XY. So notice they both have the one dash. It's a blue mark. I'm not sure how well you can see it. Let me just do like this. But angle, side, angle. So it appears on the triangle just as it's written. You have an angle, you have a side, and an angle. The included side, so this side comes from these two angles. So it's in the middle, just like over here in the middle. You're going to see below, this one's not in between the angles. So that's why it's angle, angle, side. So two angles in the non-included side of one triangle are congruent to the corresponding two angles in non-included side of the other triangle. Then those triangles are congruent. So see, it says BAC here. So BAC to ZYX. So two green arcs to two green arcs. Or maybe it's yeah, it's two, but see, it starts looking funny to me. So 2 1 0 2 1 0. But not this. So angle angle side, or angle angle side. It's not angle angle side. It's not between the two angles like it is up here. All right, get into this proof here. Let me zoom out just a little. All right, so sorry, no word bank. And I apologize for that, but I'm going to guide us through. I'll give you a little bit of a word bank for over here, and hopefully you guys can maneuver through it. We have 3 slots. I'll give you 3. So there won't be any guesswork. It's just going to be a one-to-one thing. We are going to do some practice in class with some more proofs with the word bank. Let's see. Okay, so example 1, complete the proof. We're given that BAC, so this guy, is congruent to DEC, so this guy. Let's see if I can make that look a little better. No, that didn't work, but that did. So BAC, DEC, and it's because A and E are corresponding. The C, it's in the middle here, and B and D. So first two statements, BAC, DEC are congruent. That's given. The next thing they tell us is that BD, so this line bisects AE. So remember, bisects cuts it in 2 equal pieces. So that means this side is congruent to this side, and that's the next thing they say is AC is congruent to EC, and it's a definition of a segment bisector. So as you can see, you kind of get hints as to what things are going to be during, or as you go with this through the proof. And I'm going to stop here for a second. I mentioned in the last video we would do 2 bonus words for this video. So your first bonus word for you guys that are listening and not just copying down the notes is TA, excuse me, or teacher's aid. I mentioned in class today I may need some of you guys to do some writing for me next week, and I was kind of surprised you guys were interested. So send me a message in Focus and either say TA or teacher's aid. and you get bonus points for this video. All right, so back to this. So number 4, it says vertical angles theorem. So I want to do something I've been doing. I'm hoping this will help us stick. So here in the middle of these two guys, so these triangles are butted up against each other, and so their points in the middle, their vertices, and it's hard to see, but they make an X. And those are, so in here, these are vertical angles. And vertical angles are congruent. So what you're going to have is ACB is going to be congruent to ECD. Notice how I went from the angle with the arc to the middle to the angle without the arc. Angle with the arc to the middle, angle without the arc. All how you write it's important, and those are vertical angles. All right, and so lastly, it's asking the, and hold on, before we move, let me, we'll just do it this way. All right, so these angles in the middle are congruent to each other. Remember, left to right, and then these two would be congruent. So you have an angle, you have a side, and you have an angle. Notice this side is between the two angles. This side is between the two angles, so it's angle, side, angle. All right, other side. So give you a little word bank. Let's see, let's see. You look at the actual my notes here. Hold on. So we're gonna say we have ASA, alternate interior angles, and then our other one, I ran out of space. I'll put it, your other word is angle WZX is congruent to YZX. All right, so these are your 3 choices. Obviously, you have 2 over here. That's going to be these guys, and then 1. I mean, that's pretty simple, but just look at it. I'm hoping you guys are gonna get the hang of these proofs. All right, bottom of the first page. The company is manufacturing windows. It says they want to determine the amount of glass. It's because part of the problem asks for the area, but we're not going to do that. We're just going to kind of focus on our proof and learning these sides and angles. So I'm going to try to zoom in a little more, scoot over a little more. So we're going to be looking at these angles. See, they are on top of each other, but it's going to be PQR and TRS. So they're facing each other, but these opposite sides are your corresponding. Say PRQ, so PRQ, TRS, TRS. So the first thing they tell us is that PQ is parallel to TS. That's what that means. So PQ. So, and that is shown with an extra arrow. So, and remember back to module 3, I think it was. Maybe it was 2, but we talked about parallel lines and a transversal and all those angles. So these are your parallel lines. So it's kind of like, so notice the triangles are both inside those parallel lines. So we're going to be dealing with maybe some alternate interior angles in between there. Let's see, what else did they tell us? They tell us this, but we don't need that. But they also told us, so R is the midpoint of PT. So if R is the midpoint of PT, that means this side PR and this side TR are congruent. See, it's TR is congruent, but we'll get there in a second. Let's go through. So part A, determine if whether triangle PRQ is congruent to TRS. Because PQ is parallel to TS, guess I should have put the arrow the other way. That's fine. RPQ is congruent to, so hold on, here's your first angle. So they're saying this is congruent to something else by alternate interior. So this is inside, this is the top right, so the alternate would be the bottom left. So we would say, so this was PQR, or I'm sorry, RQP. This one's going to be RST. Well, I think why did I put RTS? Did I look at this wrong? Oh, yeah, that's PQ. Idiot. Hold on. Yeah, I was like, this is weird. Hold on, bye. So, sorry about this, guys. Back it up. Hopefully you're using pencils. So, RPQ. Hopefully you guys were like yelling at the screen. What are you doing? So, RPQ. So, this would be RTS. This side, the opposite. So, top left, bottom right. So, glad we caught it there. RTS. And that's by the alternate interior angles theorem. And because R is the midpoint of PT, that makes TR congruent to PR by the midpoint theorem. All right, so TRS and PQR, so PRQ. So again, these are just talking about this guy in the middle makes an X. Those are, again, vertical angles. And it says down here by vertical angles theorem. But you got to remember where they're at to be able to locate them. So yeah, TRS and PRQ are vertical angles. So by the vertical angles theorem, again, just pointing them out. So therefore, remember this is an angle. So we have an angle, a side, and an angle. An angle, a side, and an angle. And the side is in between the two angles. So that's ASA. Angle, side, angle. All right, flipping over. So back page, we got another weird problem. This was new, and anytime it's new, I have to do some investigating. And I fought with AI because I'm like, all right, let me just see what it says. I was still right, but it's still weird. So they're talking about a theater. As you see, this looks like one of the deals over the stage. They want to know about lighting from L to N. So from L to N, they talk about, so this and this is parallel. This is parallel to this. This is parallel to that. All that is a little bit beyond what we're doing. They did tell us MN is 4. And again, they want to know what LN is. So if these two triangles are congruent, LN should be equal to MN plus LM. Okay. So we've got, let's go with so it's these lines are parallel. So these two would be congruent by their corresponding angles. Basically, just to cut through the chase, it's wanting you to understand these two triangles if they're congruent. So the angles are congruent. So the sides, if this is 4, this is 4. So LN equals 4 plus 4. So LN equals 8 feet. Again, if I had picked up or read, I don't know. I thought I read over it a little closer. Me and the other teachers, we're not perfect. So, but that is the answer. It's just kind of to me, I would have rather put something a little more meaningful in that spot. But that's okay. Moving down. So got 2 proofs. Let me let's see. How do we get you fit in there? I'm going to give you a word bank for over here. But on the left, complete the proof. RQ. So RQ is congruent to ST. So, and then RQ and ST are parallel, and they've marked those. And they're trying to prove that this triangle and this triangle are congruent. And it's like we were before. They're facing each other. This is the top of this. The opposite sides are your corresponding sides. So your first two blanks are given. So then we get over here. This is RQS. So this, and TSQ, this. So notice this is inside our parallel line, so that's interior. And it's bottom left, top right, so those are alternate. I always get myself in trouble when I put alternate interior angles. All right, so let's go over here now. This says vertical angles. Well, I'm just going to highlight it. Notice in the middle of these two triangles, just like before, your vertices make an X. And these are vertical angles, so both sides inside obviously the outsides are parallel. Congruent, because it's the left to the right, the top and the bottom. But we obviously care about the inside because of the triangle. So here, if it's RUQ, so it's an angle, and a side. It's not in between the two sides. It's over here. They tell us that. You're just going to give, so vertical angle, sorry, got sidetracked. So RUQ. And I'm going to write it bigger down here. It's congruent to TUS. Because remember, R and T go together. U's obviously go together. Then that makes Q and S go together. So A is alternate interior angles. B was angle RUQ is congruent to angle TUS. And then this, of course, we're just trying to prove triangle RUQ is congruent to triangle TUS. I'm just going to, again, write it down here. Oops, R. All right. All right, so about to see if y'all are paying attention again, if you're just taking notes or if you're just, if you actually are listening. All right, so over here on this side, we're gonna do this. I'm gonna leave this one for you guys. And I wonder, can you tell who this sounds like? So if you hear this and you send this guy's name to me in a focus message, then that'll get you extra points. Or, well, first let me set this up and then I'll give you the other word if you want to see it. So these are two triangles. If we cover up here, you can see that's one. And if you cover up here, you can see that's the other. They are asking you to complete the proof. I'll help you out here. So the first one was given, and that is that DAC, so this guy is congruent to BEC. And that DC, so, whoops, DC and BC are congruent. So we'll do this. All right, so you've got an angle and a side that now they give you the, actually we're going to go ahead and just work through it since we don't have the word bank. So this was up here, which was given. So we'll say given. Now they say that angle C is congruent to angle C. Well, and that's something that's congruent to itself, just like when you look in the mirror, your reflection is the same height and everything that you are. So that is the reflexive property. And I did it again. So this is supposed to be reflexive property. I've wasted that second space there all day. All right, and finally, AAS. So they want you to prove them. So it's that triangle ACD is congruent to triangle ECB because of angle, side. All right, let's finish this lesson off very quickly. So real quick, as I'm writing this in, so for you guys that are actually paying attention, the other word, I've noticed a couple of you guys, and I've sent busy points. Love hearing you guys talk in class to each other. A couple in particular have been real helpful to other students about explaining stuff when what I'm saying is not working, and I want to thank you for that. And that's going to be your second word, tutor. If you are interested in maybe getting some extra points by helping me, work in a small group tutoring, send me the word tutor in a message in Focus, and we'll make that happen. I'd be glad to do that and would really appreciate it. So let's finish this off. The practice, I cut this down to 1 through 7. Just a couple of proofs that I want you guys to look at, and then some of these. We did the exit ticket. If you weren't there today, we're not making up the exit tickets, but get with me. There are some similar practices. Also, we can do some McGraw-Hill or Alex. So, summary. What information is missing to prove that ACB is congruent to UVT by ASA? So, angle, side, angle. So, you have two angles. Where is that side? Is it over here? Is it over here? Or is it in the middle? So, those are your choices. I will help you out and tell you that there is missing information. And then for this one, how is AAS different than ASA? So this ASA has the included side. AAS doesn't. I'm not going to write it down. Hopefully you're listening, or if you look back at the previous page, you will see that answer. If you have any questions, please let me know. Please consider liking the video or subscribing to the channel. It helps. Until next time, have a good night.